Hi, I'm Dawson Waldner, and this is my tutorial on electrochemistry. What is electrochemistry? Electrochemistry is the study of chemical processes that causes electrons to move. Electricity is produced in a galvanic cell. A galvanic cell consists of two half cells, the anode, which is in orange, and the cathode, which is in purple. A salt bridge, which is in orange, the salt bridge, which is in green, and the external circuit, which is in blue, and the voltmeter, which is in red. We're just going to discuss what each of those do and how that consists to producing electricity in the following slides here. Anode and the cathode. The anode is a half reaction that will go through oxidation and will lose electrons and as well as mass through a chemical reaction. Cathode cell is a half reaction that will go through reduction and will gain electrons as well as mass through the chemical reaction. As you can see on my diagram here, so zinc here is the anode. So as you look in this diagram, the zinc anode here, so zinc will leave this solution here, will leave this as well as when the electrons are being going through the external circuit into the cathode. So these zinc ions will leave, and so as well as the mass here, so this will turn into that. And so when electrons go through here, the copper in the solution, copper will go into the cathode, and as that will gain mass. The salt bridge allows ions to be transferred between the two half cells, balances the charges and lets the reaction proceed. A substitution for a salt bridge is a permeate membrane, which allows ions to transfer from a half cell to another to complete the circuit. And I'll go into more detail in a later slide. The external circuit and voltmeter. The external circuit is what allows electrons to move from the anode to the cathode. The voltmeter is on the circuit, and it allows us to measure the potential voltage. Since electrons are negatively charged, the electron flow will go from the more negative half cell to the more positive side of the circuit. Calculating the potential voltage. So when choosing what will be an effective choice for the anode or the cathode, we have to see what will produce a good voltage. The formula to find it is the reduction agent of the cell subtract the potential voltage of the oxidation agent. So here's an example we're going to use. So silver and zinc. As you can see here, silver is 0.8 and zinc is negative 0.76. You take 0.8, subtract negative 0.76, and you get 1.56. So that will be the potential voltage. Now balancing a redox equation. So step one, you have to find your half reaction. So in this example, we're going to use silver and zinc. And yeah, so we have our half reaction right there. Now step two, balance the atoms except for oxygen and hydrogen. So and you see here, I just added a 2 in red so you can tell what has changed. Now step 3, balancing the oxygens by adding water. Step 4, balance the hydrogens by adding H positive. So as you can see here, you have water, which is H2O, 2 hydrogens. So you add 2 hydrogens to this side, and yeah. Step 5, balance the charges by adding electrons. Step 6, balance the H positives by adding OH negative and cancel the electrons and add the reaction. So yeah, we added our equations there, or added our atoms. In step 7, so you add the H positive and the OH negatives together, and that will form water. Then you cancel any atoms that are on both sides. So for this example, we have one water on this side, then we have two waters on this side. So one of these waters will cancel out. And so yeah, and then their final reaction is galvanic cell here. I'll just explain the process of how electricity is produced. So electrons, they're negatively charged and they will flow to the more positive side of the atom. So the cathode here will receive these electrons and the anode will lose the electrons. In this process, the anode will lose the electrons and it will lose its mass as the solid here. So the solid so the zinc ions here, they will go into the solution and it'll create, and the solution will gain a more positive charge. And as well, this will lose electrons. Then, then the electrons will go into the silver here, and the silver ions in this solution will go into the solid, and this is what creates the positive charge for the solid here, and this is why the electrons will go through. And since there are solutions here, since this solution is more positive charged, and the cathode solution is more negatively charged, that is why we need our salt bridge. So for this example, we have KNO3. So the K positive will go into the cathode solution, and that will balance out that reaction, that half cell. Then the NO3, it's a negatively charged ion, and so that will balance out the anode solution. And here are a couple questions. So question 1, balance the following half reactions and add up the overall potential voltage. So yeah, give those a try, pause it for a second. And here are the answers. Now question 2, explain the parts of a galvanic cell. Now pause it, give that a try. And yeah, here are the answers. And then here are my references, and that is the end of my tutorial. I hope you enjoyed it. And yeah, have a good rest of your night or a good day, depending what time you watch this. Have a good one.